Well, good morning or good afternoon or good evening, whichever time you're choosing to watch this. This is the first video of Math Studies, the International Baccalaureate course, and we're going to start by talking about special number sets. This is lesson 1.1. All right, and we're going to talk about some number sets that you already know. There's a set of natural numbers that starts at 0 and goes up by ones indefinitely. Then there's a set of integers that does both the positive and the negative versions of those numbers. Then we have rational numbers, and the reason they're called rational numbers is based on the word ratio. Every one of the rational numbers can be written as some integer p over some integer q, as long as q is not 0. And then there's the real numbers, and all of those numbers can be found on the real number line. So that includes the natural numbers, it includes the integers, it includes the rational numbers, and it includes some numbers that are called irrational. And those are the symbols there. That's the hollow n for natural numbers, the hollow z for integers, hollow q for rationals, and hollow r for real numbers. And as you can see, the set of natural numbers is completely contained within the set of integers. It's like a subset of the integers, and similarly the set of integers is a subset of the rational numbers, and the set of rational numbers is a subset of the real numbers. So every natural number is also an integer, every integer is also rational, and every rational is also real. Okay. You may be asked to convert any terminating decimal as a fraction because any terminating decimal is a rational number, and so we should be able to write that as a fraction, an integer divided by another integer. So for example, well, I'll just go through the steps first and then we'll do an example. All we're going to do is we're going to take that decimal. Since the decimal does terminate, there is a spot where it stops. So we're going to take the decimal and we're going to move it all the way to the right until we create an integer. So after that last decimal place, that's going to be our numerator. And then the number of places that we moved it, we're going to raise that as an exponent of 10, and that's going to be our denominator. Okay, so if I had 0.07451, I would move the decimal 5 places to the right. That would get it past the 1, which is the last decimal. So my numerator would be 7451. And my denominator, since I moved it 5 places to the right, then my denominator is going to be 10 to the 5th, which is 100,000. So if I had 0.07451 as a decimal, that would be 7,451 over 100,000. Okay. The only other kind of decimal that can be written as a fraction is one that repeats. And it doesn't have to repeat one digit, it doesn't have to repeat right away, it just has to repeat eventually, on and on and on. So here's how I handle that. What I'm going to do is I'm going to set x equal to that decimal that I'm converting to a fraction, and hopefully I'll be able to write x as something else so that those two x's would be equal to each other. Okay, I'm going to determine the period of the decimal. I'm going to look for that part that repeats itself over and over again, and I'm going to call that the period. Then I'm going to do something similar to what I did before, and I'm going to move the decimal a certain number of places to the right until it's after the first occurrence of the period, and I'm going to call that 10 to the m times x. Okay? And then starting all over again, I'm going to start from what I had before. I'm going to move the decimal n places to the right so that it's before the first occurrence of the period. So I've done two things. I've moved the decimal so that it's right after the period. That was m places, and then starting over, I moved it so that it was n places and ended up in front of the period. So if I subtract those two amounts, then I should be able to get an integer, and then I will divide to solve for x. Okay, so this is best worked out with an example as well. So here's an example of how I would do that. 0.3676767. So notice that the 67 is the part that repeats. The 0.3 is there, but it's not part of the part that repeats. So I need it, but I'm not going to consider that as being part of the period. All right, so I'm going to let x equal that 0.3676767, and as I said, the period is the 6 and the 7, repeating over and over again. If I move the decimal 3 places to the right, I will get it past that first occurrence of 6, 7. So that means I need to move it 3 places, and that's like multiplying by 1,000. So x times 1,000 would be 367.6767. Then, if I wanted to move the decimal so that it was just before the first period, I would only have to move it 1 place, and that's like multiplying by 10. So 10 times x is going to equal 3.676767. And notice what's going on after the decimal point if I do this. I did this on purpose. What's going on after the decimal is every single digit after the decimal point lines up with something exactly the same. So that if I subtract, then everything that's after the decimal point is going to subtract out and give me 0 after the decimal point. So all I will be left with is an integer. So the 1000x minus the 10x is 990x, and the 367.676767 minus the 3.676767 gives me just 364.00000, which I don't need to write. So if I simply divide, I get that x is equal to 364 over 990. So since x was equal to that decimal that I had before, and x is now equal to this fraction, both of those things are equal to x, so they are equal to each other. So 0.3676767 written as a decimal is 364 over 990. And that's how you convert a repeating decimal into a fraction. And I think that's our lesson. So if you have any questions, please let me know. You can Facebook or email me, and we will talk about it the next day.